I want to go over another great example because it brings a lot of small concepts together that we've talked about. This problem reads the analysis of metal chloride, the compound being XCl3, shows that it contains 67.2% chloride by mass. And I want you to calculate the molar mass of X and then identify the element. So in this situation, you do a Google Map technique. As you go through a word problem, always identify what you know and what you're solving for. So in this situation, first we know that the formula for the compound that we're working with is XCl3. Now one thing we see here is that we have a mole to mole ratio, and there is 1 mole of X every 3 moles of chloride. Next next piece of information we realize here is that the chloride makes up 67.2% of this whole compound. Therefore, my X must make up 32.8%, since the X and the chloride make up 100% of the compound. Then we're going after what we're solving for. In this problem, we're going to go after molar mass. So what do we need for molar mass? We need grams and moles. So I need the grams of my X, I need the moles of my X. Well, how can I get the X? Well, I can get the X by way of a mole to mole ratio. I have information about my chloride, and I realize I can set up I have 3 moles of chloride for every 1 mole of X. Well, I have to get from percent to mass, and then mass to moles. Well, first of all, remember what we said with percent composition, we're assuming 100% equals 100 grams. So we have 67.2 grams of my chloride. Now to get from mass to moles, we use molar mass, and we get that from the periodic table. Good job. So we look up chloride, and it weighs in at 35.45 grams per every mole. I put moles for grams, not grams over moles, for one reason, and that's so my grams actually cancel out. Now I'm in moles of chloride, but I don't want moles of chloride, I want moles of my X. So I know I have in my formula, there are 3 moles of chloride for every 1 mole of X. Multiply across, divide, and I get my answer. In this situation, since you have 1's across the top, you'll be strictly dividing. You have 67.2 divided by 35.45 divided by 3 equals, and you end up with 0.633 moles of X. Now I'm ready to go. I have moles, and I have my mass. How do I have my mass? Well, I have my mass because I know X makes up 32.8%, therefore it must make up 32.8 grams. So here we go for molar mass. I need my grams of X divided by my moles of X. So moles of X, well, we just solved for that. That's 0.663 moles. And where do I get my mass? 32.8 grams. I got that because I know I have 32.8%. I just simply divide and I come up with an answer of 51.82 grams per mole. I compare my molar mass in the periodic table, and I round up to 52, realizing that the closest element to this would be chromium. So we identify our unknown metal, X, as chromium. Once again, it's a great example because it brings a number of concepts together. You're dealing with mole to mole ratio, you're dealing with percent composition, and you're dealing with molar mass.